In this video, I will explain you what is telescope and its magnification. Okay. Now, in a telescope, why we are using telescope? To see stars and these planets which are very far away from us. Now from there we will have the lights coming parallel to each other because the source is very far away from us, so it would be a plane wavefront or the rays would be parallel to each other. Now we need to bring all the light rays to one point, and that has to create an image, and that should be an enlarged image that has more details about the source. Okay. Now, so these are parallel rays. We can't bring them parallel in such a way that is parallel to our principal axis. But we know one thing: any parallel rays, if that is set of parallel rays, then that would focus at one point. But that is not focus. That would intersect at one common point. That point would be in the focal plane. So we have two lenses here, right? One is objective and other one is eyepiece. Eyepiece is near to eye, objective is near to object. But here object is very far away from us, but anyway it is far away from our eye. This is having larger aperture, this is having smaller aperture. Now light ray will focus at and intersect at one point. This point is not focused, but it is in the focal plane. How will you get the focal plane? Just take a plane and just take a plane and make it perpendicular to the principal axis and pass through our focal point. So we will get the focal plane. So focal plane is nothing but set of all points in this line. So these lines would intersect somewhere in this line. So this is our focus of objective. Okay, this is our objective and this is our eyepiece. Now it has created an image here, but this is a smaller image, right? We need an enlarged image. So what we will do, we will keep this image at the focal length of eyepiece in such a way that the rays sent from here. So one ray is through optic center and other ray is parallel to principal axis, and after refraction that would go in this direction. So we need the intersection of these two rays. They never intersect, so we can say that they would intersect at a very large distance, and that would create a very big magnified image of A dash B dash. So how to get the magnification here? This is the working principle. From star, rays are parallel, they intersect at one point and creates one image, first image. Now this image would act as the object of this lens, and this image is kept, or the object of this lens, that is the image of this lens, is kept at the focal length of eyepiece. Now focal length of eyepiece, we made this image possible at this length. Now this image would act as object for this and would create an image somewhere here. That would be an enlarged view. So to get magnification in this case, we can't go with V by U. We have to go with this equation, angle subtended by image at our eye divided by angle subtended by object. Now what is angle subtended by image? So image would be somewhere in this line, so it would be beta, and angle subtended by object. Now from object, this is the ray coming, so this is the angle subtended by object. So angle subtended by image is beta here because our image is here. Angle subtended by object is alpha because these are the rays coming from object. Now beta by alpha, for small angle, beta by alpha can be written as tan beta divided by tan alpha. Now from this triangle, what is tan beta? A dash B dash divided by C2 B dash. So A dash B dash divided by C2 B dash is the tan beta from this triangle. Now tan alpha from this triangle is nothing but A dash B dash divided by C1 B dash. C1 B dash. A dash B dash will cancel because these are in the numerator. So this would be C1b dash divided by C2b dash. What is C1b dash? C1b dash is nothing but focal length of objective, and that is measured in this direction, so positive. Now what is C2b dash? C2b dash is focal length of eyepiece, and that is measured in leftward direction, so that would be minus Fe. So equation would be minus Fo divided by Fe. So magnification of telescope is equal to minus Fo divided by Fe. This is a very important relation. Now this is the reason why telescope is very larger. See, microscope is smaller in length, approximately 30 centimeter, 30 to 50 centimeter, but our telescope is very larger, right? In feet it is measured. The reason is, for a larger magnification we need smaller eyepiece, smaller focal length for eyepiece, and larger focal length for objective. So when the objective become larger than the total length, so larger objective means, so I have to bring my objective somewhere here. Now see, the distance become between the eyepiece and objective become more. So because I know that length of the telescope is Fe plus Fo. Now when I am increasing Fo, then the total length of the microscope become increased. So Fo, higher the Fo, higher would be the magnification for telescope, and that is the reason why telescope is having a larger length. Okay, thank you.